Hello, Math 2 students. I hope you're ready to review everything that you know about graphing quadratic functions. So to start with, we're going to graph the function g of x equals 2x squared plus 4. They're also asking us to compare this function to the graph of f of x equals x squared, which we should recognize as the parent function. So the first thing I'm going to do is graph the parent function. This should be automatic for you by now. I know the parent function has a vertex at 0, 0. I know the next point on the parent function is over 1 and 1 squared is 1. And over 2 and 2 squared is 4. And there will be symmetrical points on the other side, so negative 1 and 1, negative 2 and 4. And my parabola will look like this. And that is the graph of f of x equals x squared. That is our parent function. Now, to graph this function, we need to find our a, b, and c values. So on this problem, our coefficient under x squared is 2. So our a is 2. We don't have any x term in the middle. So our b value is 0, and our c value is 4. Now that I know my a, b, and c, I'm going to go ahead on this problem and I'm going to find the vertex. So the x-coordinate of the vertex is negative b over 2a. So we have the x-coordinates negative empty bracket over 2 empty bracket. My b value is 0, my a value is 2. So that's 0 over 4, which is 0. So the x-coordinate of my vertex is 0. Now for my y-coordinate, I'm going to go y equals 2 empty bracket squared plus 4, and my x, which will fill in the x in the function, is 0. 0 to the second power is 0, times 2 is 0, plus 4 is 4. So my vertex is 0, 4. That is exactly the same thing we would say if we were saying that it was a vertical translation of 4 units, because our vertex will be 1, 2, 3, 4 right here. So that is the vertex of this function. Now I know that there's going to be a vertical stretch of 2. So on the parent function, I go over 1 and up 1. So here I would go over 1 and up 1. So I have a vertical stretch of 2. So instead of over 1 and up 1, I'm going to go over 1 and up 2. And that's going to put my point right there. And then I'm going to have a symmetrical point on the other side. So negative 1 and up 2. It's going to look like that. When I go over 2 on the parent function, I would normally go up 4. But because of the vertical stretch, I go over 2, and now I'm going to go up 8. And then there's a symmetrical point on the other side. So this graph will look like this. It's a U-shaped parabola. It's a curve. Because of the vertical stretch, it's narrower than the parent function. And because of the c value of 4, it's translated up 4 units. And we found out that was true also if we calculated the vertex is 0, 4. In this problem, they're telling us that the function f of t equals 16t squared represents the distance in feet a dropped object falls in t seconds. And then it says an egg is dropped from a height of 64 feet. After how many seconds does the egg hit the ground? Well, the first thing that bothers me about the problem is they're talking about the distance, which is the height since it's a falling object, and they're using an f. So to make it easier for me to remember what's going on here, I'm going to call it h of t equals 16t squared. So now the height as time passes is represented by the function 16t squared. Now in our problem, what is the height? Well, our egg is dropped from a height of 64 feet. So the height is 64 feet. So we have 64 equals 16t squared. This is a quadratic function because of the t squared. So I'm going to subtract 64 from both sides. And I'm going to put this function in standard form. So I have 0 equals 16t squared minus 64. I can see that I have a greatest common factor on this problem of 16. So I'll write it like this. 0 equals 16. And then my remaining, in this case, binomial is going to be t squared minus 4, because 16 times 4 is 64. So my remaining polynomial, this is a perfect square, that's a perfect square, that's a minus sign. This is the difference of two squares. So that will leave me with a sum and difference pattern. So I'll have 0 equals 16 times t plus 2 times t minus 2. And then I have to use the zero product property. So t will equal negative 2 and t will equal positive 2. Now, on this problem, we're talking about the time it takes for the egg to fall 64 feet. And since we're talking about time, this answer doesn't really make sense because we can't have negative time. So this answer is out, and the correct answer on this problem, after how many seconds does the egg hit the ground? The egg hits the ground after 2 seconds. On this problem, they want us to graph y equals negative x squared minus 16x minus 9. On our way to making this graph, we are going to need to find the vertex, the axis of symmetry, and the y-intercept. We're also going to need to find a third symmetrical point, and then we're going to find the maximum and minimum once we make the graph, and the domain and the range. So the first thing we need to do is identify our a, b, and c. My a on this problem is negative 8, the b is negative 16, and my c is negative 9. So I'm going to find the vertex, first the x-coordinate of the vertex. So x equals negative b over 2a. So x equals negative empty bracket over 2 empty bracket. My b value is negative 16 and my a value is negative 8. So we end up with positive 16 over negative 16, which is negative 1. So the x-coordinate of my vertex is negative 1. Now for my y-coordinate, y is equal to ax squared plus bx plus c. And on this problem, y is equal to negative 8 empty bracket squared minus 16 empty bracket minus 9. And I just found out that my x is negative 1. So I'm going to put a negative 1 here and a negative 1 here. And I get y equals negative 1 squared is 1 times negative 8 is negative 8. Negative 16 times negative 1 is positive 16 and negative 9. Negative 8 and positive 16 is 8. And 8 minus 9 is negative 1. So my vertex is negative 1, comma, negative 1. All right, I know that my axis of symmetry is always going to match the x-coordinate of my vertex. So my axis of symmetry will be the line that has the equation x equals negative 1. I know my y-intercept is going to be my c value, so my y-intercept is negative 9. So I'm going to start the problem by putting my axis of symmetry on the graph, a vertical line that passes through negative 1. So there's my axis of symmetry. My vertex is at negative 1 and negative 1. So my vertex is right here. My y-intercept is at negative 9. So I'm going to go to negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my y-intercept. Now, I'm going to have a third symmetrical point on the other side of the axis of symmetry. This is only one space. So I'm going to have a point 1 space away on the other side of the axis of symmetry. So there's my third symmetrical point. And so now my graph is going to be a U that opens down with a vertex of negative 1 and 1 and a y-intercept of negative 9. So my third point of symmetry, just so we can record it, is negative 2, comma, negative 9. Okay, my maximum or minimum value. Since this parabola opens down, it's going to have a maximum value. It's going to have a top where there are no points any higher than that point. And the maximum value always matches the y-coordinate of the vertex. So my maximum is -1. There's not going to be any points higher than that. And then finally, my domain and my range. The domain is all real numbers. And for my range, the y-coordinate of the vertex, or the minimum and maximum, helps me out. In this case, remember, this is the maximum. So my range, if I think of all the y-coordinates that could possibly be on any point on that graph, I'm never going to have a y-coordinate that is greater than -1. So my range is y is always less than or equal to -1, because every y-coordinate of every point on my parabola will be -1 or less.